This is lecture 21, example 2. This is an example related to the previous example. It's essentially what we're going to do is extend the lookup table from 16 based on 4 bits to based on 8 bits. That's going to allow us to do this problem a little bit more efficiently. So essentially we're redoing the parity. We're going to use a lookup table, and we're going to use a lookup table that has 256 locations, and the 256 locations are going to be the number of bits that are set in an 8-bit value. And so I'm not going to redo this from scratch. I'm actually going to start from this code here. And so this is our code for 8 bits. Certainly we're not going to put in 256 of these, though it wouldn't be that much trouble. But we're just going to skip that part of it, and we're going to go directly over to the Venus and modify this code and then make a comparison, see how much quicker it runs. Okay, so let's get out of here and go to Venus. Okay, so here we are in Venus, and we want to modify this, at least the code part of it. We're not going to do the text segment part of this, to work on let's say 8-bit lookup table. I don't know if that's right. So this is going to be the number range that it's going to be looking up is essentially 8 bits. So it's 0 through 255. So that's 8 zeros through 8 ones. So this is we're just going to pretend like this works. This is actually the lookup table data is not correct anymore. So let's fix this thing. So now I'm doing it instead of 8 chunks of 4, I'm doing it in 4 chunks of 8. So my counter is going to be 4. I'm going to have to clear the register. So that can be okay. And I am still going to store the base address, so that's okay. And so let's go through this thing. One value here. So this is blah blah blah. That's the while loop, that's okay. And this is the first thing that needs to change. So what I want to mask is the value. I'm not working with nibbles anymore, I'm working with bytes. So I increased the mask length from 4 bits to 8 bits. Okay, so at that point I'm going to add this x21, which has the value in it, which is my offset. So I'm add the offset here to the base address, which is the address of the lookup table up there. Add them together. That's going to be my absolute address in x22. So I go to x22, get that data, and I store it in x22. And that's heck, I think that's all I need to do for this. I think something down here needs fixing. Certainly that's not shifting by 4, it's now going to be shifting right by 8. And at that point I think I'm done with this problem. So let's go ahead and count up how many times this runs. It's probably a better way to do that, but heck, I'm going to try this. I'm going to hit this button here. Maybe I can draw on it. Okay. Probably didn't get in trouble with that, but let's see if it allows me to draw. Oh, it does. Okay. So this is going to be a 2 on a 2 on a 2, and this is going to be, oops, same thing. It's going to be 2, 4, 6, 2, 4, 2, 4, 6, 8, 10. I better write it. 2, 2, 2, 3, 2, 2, 2, 2. And this is going to be done 4 times. And the last 2 instructions here are 2 and a 2. So total is going to be, and there's going to be an extra 2 for the final jump there. It's going to be 6 plus, okay, this is 6 plus, we'll do the last ones, plus 4 plus 4 times 2, 4, 6, 8, 10, 12, 14, 16, 18, 19, 2 2, 4, 6, 8, 10, 12, 14, 16, 17. And then there's going to be one more for 2 coming back through this time. Okay, so this is going to be, where'd it go? This is going to be 4 times 17, which is 40, 68, which is 70, 80. Okay, so if we use this much larger lookup table, 256 location lookup table, it is going to be bytes. I can actually execute this subroutine in 80 clock cycles. That's compared to 394 for the non-let, and as compared to, I think it was 148 for the nibble-based let. Okay, so the issue is the code's the same length. This is going to grow significantly. Well, not significantly, but, well, significantly. And more memory for data. The program itself is the same size, but in the end, I can execute this in 80 clock cycles. So it's significant savings over the non-let and even over the let. And so anyway, interesting stuff. Some people actually care about this, and we'll call it done there.